Well, hello, it's KP the Math G, and as you see already, I have a bunch of stuff here. This was actually part one of approximating area using rectangles. And what we were doing last time, we did the left and the right hand rule. The left hand rule being, and this was from yesterday's video. What happened was I got to the left and I completely discussed that one. But when I got to the right, I got almost all the way done and my camera stopped. So evidently I need more memory than what I have now. It's an old camera and I'm just going to need some more memory for it, but I'll figure that out later. Getting back to the lesson, when we did the left hand rule, we started with the left hand most side, delta x being 1, just a brief summary of what we just did, just in case you weren't able to see the video. And we determined delta x when we said that there's a formula for finding that. That's b minus a over the number of rectangles that we put together. We wanted 4 rectangles, n equals 4, so 4 over 4 is 1, so delta x is 1, okay, and each triangle is supposed to be the same width. Evidently I have my numbers spaced out differently, but needless to say, I'm terrible at drawing anything close to scale at all, but you have the idea. What's happening here is that when we approximate what's underneath this curve here, if you can see that curve, you found that area 1 plus area 2 plus area 3 plus area 4, the sum of these rectangles, the sum of these areas equals 50. Okay, so on the left hand rule you started off at F at 0. F at 0 is the height. F at 1 is this height, F at 2 is this height, F at 3 is this height. Okay, you don't deal with F at 4 because F at 4 is not touching the pink curve. Okay, so we got an area of 50. So when we did the right hand, that's the left hand rule. When we did the right hand rule, of course, there it is. It looks really nice, doesn't it? We started from the right. We noticed that from 3 to 4 there is no rectangle, and we only just summed up 3 rectangles and found that we started at F1, F2, F3, and F4. Okay, to the right, we just count backwards. F4, F3, F2, F1. Since n is 4, you stop there. From the right, you had F0, F1, F2, F3. That's the left side. This is the right side. Okay. Alright, so we summed this up and got 34. There's quite a discrepancy between 34 and 50. So as you notice, there's a lot of area that's missing here, okay? Not accounted for, okay? So what we have to do here is simply add these two up and divide by 2. So 50 plus 34 divided by 2. This is 84 divided by 2, and obviously that is 42. Alright, that's pretty close to what we are looking for. Later on we'll find out what the actual is. We're going to keep on with this f at x equals 16 minus x squared throughout. So really we did 2 approximations. One, the left side rule, which gave us 50. The right side rule gives us less than that, which is 34. We took an average and got 42. And that's basically what you want to do, is get an average. You want to average the left side or the right side. But on the test now, on the AP test, You may just be asked to find the left-hand approximation or a right-hand approximation. Okay? And then, of course, determine if this answer, if you had to find the left one, is it an over approximation? Well, yes, it is, simply because the function f is decreasing and the triangles extend beyond there's just too much area to account for here. Okay, that's what it is. Okay, so here, an overestimation. This one, a grossly smaller approximation here. So therefore you need to get an average, 42. Okay, that's kind of where we left off from last time. What I want to do this time is do another one, but I want to do it by the midpoint. There's actually 4 of these that we're doing: left hand, right hand, midpoint, and trapezoidal. There is also Simpson's rule, which I need to look into, that's kind of similar to the trapezoidal, but we'll look at that for another time. I'm not sure that Simpson's rule is part of the AP training teaching, so if it is, I'll throw it in there. But needless to say, we're just going to look at these 4 and probably look at a table also, a couple of tables, a problem that deals with that. I've been looking at those ahead of time. But now let's look at the midpoint. What is that? We're going to look at the same problem. Okay. Yeah, I keep everything written down. Look at that. It's all right there. All of them on one page. Okay. I try to stay ahead a little bit. I'm going to keep this picture here. We're going to have to do a little erasing. Here's the original problem. So now part 2 has to do with the midpoint, doing the midpoint. And there's a benefit for the midpoint that's different than doing just either the left side and the right side rule. So let's erase our rectangles. Okay, all this looks like area. Okay, let's erase our rectangles. Okay. Bear with me, please. I appreciate your patience. I appreciate you watching the video. That's very nice of you to do that, and being patient with me above all things. Okay, there we go. Let's erase this F1, F2, F3. Okay, there we go. Alright. Alright, now, what does midpoint mean? Well, we know that delta x is equal to 1. Okay? Delta x is equal to 1. There's delta x. And it equals 1 unit. So 1 is equal to delta x. So let's see. So for each one of these segments, we already know that delta x is 1. We're keeping that the same. We're only looking at 4 rectangles again. I keep wanting to say triangles, but they're rectangles. So let's draw our figure again. I'll try to fix this up a little bit. Alright, nurse it up a little bit. There we go. Okay. Alright, so, raise this out to 4. We don't need it. Okay, there we go. Alright. Now, let's go ahead and get started. Delta x equals 1. Well, what's halfway between 0 and 1? Well, you got it. It's a half. Alright, you got it. It's 1/2. Alright, and then we're just going to keep going between 1 and 2. Well, we know what that is. It's 1.5. And one way to do it is you can just simply add 1 plus 2, 1 plus 2, and then divide it by 2. That's what midpoint really means. 1 plus 2 is 3. That's 3 over 2, which is 1.5, isn't it? So that's another point right there. Now let's see. Let's put a dash here and a point right here. And we'll call it 3 halves. That's 1.5. 1 and 1/2 right there. Between 2 and 3, we know what that is. That's 2.5. Alright, so again, if you want to, 2 plus 3 over 2, that is 5 over 2. Let's get a different color. I want another black color. We're going to put that at the end of the line because it's just not showing up well. Alright, so 5 halves, which is 2 and 1/2. A little bit better, isn't it? So 5 halves is right here. 5 over 2. Okay, and that's also 2 and 1/2. And you can probably guess this is 3 and 1/2. 3 plus 4. 3 plus 4 divided by 2. That's 7 over 2, which is 3 and 1/2. Okay, so 7 over 2, which is the same as 3 and 1/2. I like to leave it as improper fractions. It's going to be easier for us to do that. Okay, our delta x is still the same. Okay, so this is what we're going to do right here. I'm going to draw a dotted line. Let me look at my picture here. Yes. At the midpoints, I'm just going to simply draw a dotted line until I touch. Okay, so right up, straight up from here is F at 1/2. So F at 1/2. Okay, it's a dot. I'm going to make it a dotted line because there's a reason. Okay, and I want to erase that for now because I want you to see the full picture. Okay, let's dot this line as straight as we can down to 1/2. Okay, there we go. It's the dotted line. It's dotted because that's not really my rectangle. This is not my rectangle. My rectangle delta x is still 1, so I'm going to make that one solid. Get a different color. I want to make that one solid right here at 1, and it's going to go up solid right here. Okay, boy, you can tell I draw straight lines. Let me try that again. Okay, and it's probably not going to be any better, but we're going to try. Well, okay, a little better maybe. Okay, so what we're doing here is we're going to extend to that point right there. Okay, and we're going to come straight across through that point right there. And you can almost see that there's a little bit of gap here and a little bit of gap here. So you got a little bit under the curve and you got a little bit of gap above the curve, and that's, you kind of get the average of that anyway. So it kind of makes it a little bit more accurate. Now, a left side alone or a right side alone. The thing about this is, if you do the left side and the right side and take the average, you're doing really the trapezoidal rule, which we haven't done yet, but you'll see as the answer was 42 on our last video, that will be the same answer for the trapezoidal. But we're doing midpoint right now. So the midpoint between 1 and 2, we're going to get that dotted line right here, straight up like that. Okay. And we're going to draw our and right there, that point right there. This is F to the 1/2. Okay, right there. But the next one right here is going to be F to the 3/2. 3/2 right there. Now let's draw our triangle straight up. Now it's got to go up even with, you can't stop on the curve. You got to get even with the point right here. So go up above the curve until you're even with the point. Now watch what happens here when you go straight across. See, you got some area That's unaccounted for, and you got too much area here. So a little bit of an average there, isn't it? And that's why this is more accurate, as we're going to find out just shortly. Okay, 5 halves, dotted line, straight up. Da 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 da. Okay, 3, draw the line. Okay, let's see. Straight up, right there. But you got to go beyond. There's that point right there. Go beyond that point, and then go straight across through that midpoint right there. That's why it's the midpoint. Okay, a little bit still. Look at area here below the curve. A little bit of area above the curve. That's good. Probably the same amount of area here as it is here. Okay, finally 7 halves, straight up, blah, 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 blah. To that point right there, if you go straight up, above there. Okay, this is, by the way, let's go back. This is F at 5 halves, 5 over 2. And then this one right here is F at 7 halves. That's that height, isn't it? Let's put it a little bit higher up. F at 7 over 2. Alright, we're going to draw the triangle. Wow, it's going to stick out just quite a bit here. We got to get even with this point, even with that point right there, and then draw straight across. And notice right here, area under the curve is a little bit less than this area here. And of course, this is not drawn to scale either, so keep that in mind too. So we have F at 1 half, F at 3 halves, F at 5 halves, F at 7 halves. What are these? This is the height. Okay? This is the height of this rectangle. This is the height of this rectangle. This is the height of this rectangle. And this is the height of this rectangle. And we do have a function of F. So if we plug in each one of these, 1 half, then 3 halves right here, then 5 halves right here, and then 7 halves right here, we'll find that this represents, by the way, boys and girls, ladies and gentlemen, this represents the height. This is the height of the rectangle. Okay, that's the height of the rectangle. Alright, let's erase all this other stuff. Okay. So we're going to figure out what these 4 areas. Area 1, area 2, area 3, area 4. We're going to figure out what all those areas are. Alright, and come up with an approximation. Alright, so let's see what we get here. Alright, so let's see. Let's see. How do we do it? It is length, or width, times length, or height, times width. So here's the summation here. Summation at so I is equal to 1 to n, which is, well, I mean, it's going to be 1 half, isn't it? We're going to start at 1 half. Okay, now 1 half, and we're going to go to n is equal to 7 halves. Alright, actually that's what we're going to do. We're going to sum those up, and we're going to, that's going to be F at x of I delta x. Okay, I have to study that to make sure that's correct. We're looking at 4 different things here. We're adding up from 1 half to 7 halves. That looks good to me. So let's go ahead and get started here. Okay, so we're going to add them up. So delta x is 1. So it's actually 1. So the first one, the first area is 1. Area is equal to 1 times 1 times F at 1 half, okay, plus 1 times F at 3 halves, base times the height, plus 1 times, so let's put it right here, 1 times elf at 5/2. Okay, so plus 1 times elf at 7/2. And if this were anything other than 1, even if it is just 1, you could easily just erase the 1s and put it on the outside. So if it's like a 2 or 3, but in this case it's 1, okay, like that, and that way you don't have to worry about one. But this gives you the idea when I did it this way. I did it that way to show you that that's your width times your height. Okay, so you have a common 1, you can just take it out. Okay, well, let's figure out what f to the 1/2 is and put it down here. So 1 times, alright, so f to the 1/2, and I think I figured that out. No, I did not. Okay, so I'm going to figure them out. Okay, here we go. Well, 1/2 is right here, so let's do this. F at 1/2 is 16 minus 1/2 squared, which is 16 minus 1/4. 1 times 1 is 1, 2 times 2 is 4. And then if you want to get I want to keep it in terms of 4, so really this is over 1, so I'm going to multiply both sides up and down by 4. I want a common denominator, right? So 4 times 16 is 64 over 4 minus 1/4, and that's 63 over 4. Okay, so this is 63. I'm just going to leave it as improper form right now. So F at 1/2 is 63 over 4. F at 3/2, let's figure out what that is. Okay, so 3/2 right here. Oh, these would be 3/2 here. All right, so 3/2 is 3 squared is 9, 2 squared is 4, so 9 over 4. This is still 64 over 4, isn't it? Okay, so 9 over 4. So 63 minus 9, 64 minus 9 rather. 14 minus 9 is, let's see, is that 55? 55 plus 9. 5 and 9 is 14. 5 and 1. Okay, so 55. So plus 55. 55 over 4 plus, okay, and it should be getting smaller and smaller each time because our function f is decreasing. Alright, so let's see, let's go ahead now and try now, let's see, 5/2. Alright, so 5/2. So f at 5/2. So here we go. 5/2. Okay. 5 over 2. Okay. Now, again, that is 25 over 4. 25 over 4. So 25 here. So 25 over 4. Alright, here we go. 14 minus 5 is 9. And then 5 minus 2 is 3. Alright, let's make sure. 39 plus 25. 9 plus 5 is 14. Carry 1. 2 plus 3 is 5 plus 1 is 6. So 39 over 4. 39 over 4 plus, okay. It looks like all of these are odd numbers. That makes sense because our numerators are all odd. Well, this should have been, okay. Okay, so this should have been a 5 here. 5 here. Okay. No, I don't know. I was just writing it out. Okay. Yes, okay. 1/2, 3/2. I'm getting lost on my board here. 5/2, 7/2. Okay. Okay, so let me block this in so I won't forget it. I'm going to erase this part here. Right here. sometimes my board gets so cluttered I have to erase so I can see where I'm at. Okay, here we go. And let's see, we're going to leave that there for now. Okay. Yeah. Okay, so let's see, right here. Okay, right there. Okay, now I want to do now F at 7/2. Okay, so let's make this a 7/2. 7/2. Let's get the darker color. Okay. Alright, 7/2. Thank you for bearing with me on these. 7/2. 7/2. Alright. We don't need this. We already know that 16 is 64/4. This is going to be 16 over 7 times 7 is 49. 2 times 2 is 4. Okay, so we have 49/4 here. 49/4. Alright, so let's see. What is that? 14 minus 9 is 5. And 5 minus 4 is 1. So this is actually plus 15/4. Okay. That looks pretty good to me. Alright, so. Alright, so let's see. 63 plus 55 plus 39 plus 15/4. So this answer is going to be over 4. Let's see what we get here. Let's do the ones with 5. 55 plus 15 is 70. Alright, so we have a 70/4. Isn't that right? 5 plus 5 is 10. 5 plus 1 is 6 and 1 is 7. 39 plus 63, that's those two. So 3 plus 9 is 12. And carry 1. 6 plus 3 is 9 and 1 is 10. So 102/4. Yeah, I think that's right. 3 plus 9 is 12. And then carry 1. 6 plus 3 is 9 and 1 is 10. 55 plus 15 is 70. That's good. So now let's add this up. 0 plus 2 is 2. 7 plus 0 is 7. And then 172/4. And I don't know if that divides evenly, but we're hoping that's pretty close to 42. That's what we got when we averaged the left side with the right side. So let's figure out what we got here. 172 divided by 4. I have a calculator, but don't worry about it. 4 times 4 is 16. Got 1 left over. Hey, 4 times 3 is 12. We got an answer of, so in this case, we got 43. 4 times 4 is 16. 4 times 3 is 12. So in this case, the area is equal to 43. All right. Remember, the last area was the average between the left and the right side. Approximations was 42. This is 43. And let me just emphasize that if we could get smaller triangles, instead of 4 triangles, maybe 8 triangles. Maybe 16 triangles. We would get closer. We'd have less gap here. See? We'd have less and less and less gap on the outside. And less gap on the inside too, by the way. Okay? So the bigger the more triangles you have, delta x is going to be smaller and smaller, and you're going to eventually, if you have an unlimited number, such as infinity, an infinite number, it's just going to make out the curve itself. Okay, that's crazy. It's crazy good, isn't it? Okay, that's why these are called approximations. Alright. Anyway, that's how we do. And by the way, let me erase this. And let me emphasize what we just did now. This is called the midpoint approximation. Midpoint approximation. Again, delta x is still 1. Halfway between 0 and 1 is 1/2, so we had to deal with F at 1/2. Between 1 and 2 is 3/2, so F at 3/2. Delta x is still 1, but between 2 and 3 is 5/2. Between 3 and 4 is 7/2. So we summed each one of these up. We found F at 1/2 to be 63/4, F at 3/2 to be 55/4, F at 5/2 to be 39/4, and F at 7/2 to be 15/4. And when we summed all of these up and multiplied by 1, by the way, you got to remember, 1 times all of this is still all of this, so that was okay. But you got to remember that there could be a different number other than just 1 out here. It's not going to always be 1. Delta x is that the thickness of the triangle, of the rectangle rather, is not always going to be 1. So just remember